See where we have to spend some time with discussion. Today I do have time for a question or two, if anybody has one that's specific. A person who has been giving me a fair number of questions is Salvador. And Salvador's questions have been out of L'Hopital, which I found rather interesting. But anyway, Tanner.
Can you do 32B?
Give me page.
Page 317.
Okay. And you said 32D. 32D. Okay. Now, these have to be put in summation notation. And how many numbers do we have here?
4. 63.
D? 32D?
49.
I think there are 49 numbers. And so I think what we could do there is go n equals 1 to 49. And this is going to be 1 over n times n plus 1. That's one way to do it. There are others. Yes? Oh, just a second.
Okay.
Follow up? Okay, yeah, there's some.
So for like those three, like if it starts at 3 or something, can you do n equals 3?
Yes.
Okay.
Mm-hmm.
I thought you had to start at n equals 1 every time.
No, you don't have to. You can start wherever you like. So you can start at 3, but then make certain you get to the high points. Yes?
Is it easier to make a formula so that you can use n equals 1?
I like to do it that way. You're looking at probably C.
Yeah.
Okay, take a look at that. Now, this is just a quick review of summations, and those are all arithmetic series. Okay, and when we did an arithmetic series, we did this. Now, here's where we're going to go first. We'll just go even numbers. 2, 4, and it's going to be a series, plus 6, plus, and we're going to go dot, 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 and we're going to get to 12 over here. How do I get to this number? Well, this number is going to be, this one is always going to be, what's my difference here? My difference is 2, right? And my a sub 1 is 2. And I don't know what that one happens to be at this point, but I could figure it out. But a sub n is going to be my first term plus n minus 1 differences. This one doesn't have a difference. But that one has a difference. And that one has a difference. And they all have differences up to here. That's why it's 1 less than all the differences. We've done that. So with that in mind here, I could go this way. And my last number is 63 equals a sub 1, which is 3. Plus how many numbers I have, I don't have a clue. And this is equal to 63. Just a second. No. The difference is how much? 5. 5. Okay. And so this gives me 60 equals n minus 1 times 5. So this gives me, divide by 5. And this gives me 12 equals n minus 1. And already somebody said n equals 13. Okay? So you've got that. Now when you got that, how about what is the generating term for this last term? Well, we can go back to this again. And I want this. A sub n is all of those, and we're going to go counting now 1, 2, 3, 4, all the way through, is equal to the first term plus 13 differences times 5. Oopsie, do I want that?
Isn't it 13 minus 1?
Just a second. Equals 3 plus n minus 1 times 5. This is what I wanted to really do instead. And so this gives me 3 plus 5n minus 5, or it gives me 5n minus 2. Okay, summation, n equals 1 to 13, and see if I have it. Put a 1 in here, that gives me my 3. Put my 13 in there, and I get my 63. Correct? So that's how you can do it with algebra. Sometimes you have to hit and miss. But if they're arithmetics, you can always do it this way. All arithmetics will work this way. Okay? Now, I might go back to this next week, Wednesday. because next week, Monday, we have a regular day. Tuesday, we block. And so on Wednesday, my goal is to do the fundamental theorem of the calculus and a few other things. I would like a test early, but it's not lending itself to it, so we might have to do 2 of them. Yes, go ahead.
Did you say we have block on Tuesday?
Yes.
Why?
Because Thursday is grandparents' day.
Yes. Okay. Thank
So
you,
is Thursday
thank you,
block
Aaron.
on- Thursday block is on Tuesday?
Say it once.
Is Thursday block on Tuesday or is Wednesday
Oops.
block on
No, we're here on Wednesday.
Tuesday.
Wednesday.
Is
Okay.
Tuesday.
Okay.
Okay.
Okay, thank you.
Yeah.
Now, so I don't, Dylan, make certain I'm finished, flag me at least by 3 o'clock, okay? Now, I'd like to just do a few things with you so that you get an idea how things work here. Because these are kind of cool. Page 327. Let's go to 327, let's go to 329 first. First 329, okay? Now, there's some really cool things there, and we'll see how they work in terms of a problem. Now, the first one in that table of things, if you have an integral from a to a, it's going to be a 0. Make sense? Geometrically? Okay. Now, notice the next one. It says, if I do this, from 1 to 2, f of x like this, dx, it's going to be just the opposite. See, then we have something going like this. Here is my sum, and here is 1, and here is 2, and in this case, I'm doing all these Riemann sums this way. It's going to be the opposite of going from 2 to 1. Okay? F of x, dx. Got that? I haven't proven it, but that's one of the properties in this table. This one is the opposite of this one. This one is going from here to here. This one's going the other way. And I'm adding all, kind of adding, but they're all going the other direction. Any questions about that? Okay. Now, the next one is kind of obvious, I think. 3. Any questions on that one? The sum of the derivatives of the derivative of the sum. Okay? Now take a look at the next one. Again, I think it's pretty easy. Are you with me? Please be with me. Okay, now I'm going to go to the next one. That one is pretty cool. And we'll call this A. We'll call, oops, I got too much junk up there. Let me just get rid of this whole business and do it over. We're going to, you got this. We're going to go from, I'll just do a picture. We're going to go a function like this, and here is A, here is B, and here is C. Okay? And this is what he has. He says, no, he did it differently. He has B over here, and C is in the middle. He says the derivative from A to B of f of x dx is equal to from A to C of f of x dx plus from C to B. This is a C to B f of x dx.
You're doing number 5?
Pardon?
Number 5?
That's number 5, yes. Okay? And then he does an absolute value one too. Okay? Now I'm going to go back a page, and he has, what does he have in the middle there? We've done that one already. We got it. Yes?
Why would you use that one?
Why would we use it? We're going to use it a lot of times, and I'll tell you why. What we're going to land up with one of these days is 2 functions that are going to crisscross in each other. We're going to have something like this. And what I'm sharing with you isn't all that difficult. We're going to have a function that goes like this, and we'll call that my f function. And then we're going to have my g function, which is going to go like this. Okay? This is my g at x function. Now, notice what happens here. Here, blue is on the top. And I'm going to be taking Riemann sums not from here to the bottom, but just between these two. And it's not all that difficult. Okay? Okay? And now you will notice that these are from the red one to the, or the actually orange here, to this one. So they're going to be kind of opposites of each other, and that's how we're going to use it, to figure out from here to here, and then from here to here. And so we're going to do a whole bag of things. We're going to whirl these things around, and lots of nice stuff comes out. And some of it is not all so hard. Okay, now, I've got that done. Let's go to a problem that I have up there. Oh, by the way, we should talk about that reading assignment too. Let me do problem 60 first, and then I want to talk about that reading assignment so you can do it to make sense. That you don't overdo it, but do at least enough.
On page 31.
We are on page, where am I? Okay, page 332. Page 332, and let's take a look at problem 40. Problem 40. You'll notice you'll be doing 39 and 41, and notice what we have here. He says we have a nice little function here from 1 to 4, and it's an f function, and he just tells me that's equal to 8. Oh, that's cool. Okay, then he says we also have a function from 1 to 6, which is also that f function, dx, and that's equal to 5. Okay? Now, with that in mind, we have to do some of these problems below there. A, B, C, and D. Let's do A first. Can anybody quickly give me the answer to that thing without doing anything? Negative 24. Okay? Because this is what we have. We have a negative 3 over here, and then we have an f of x dx like this. But this negative 3 can come out here. We just saw how that could be done that way, and we know that this is 8. 8 times a negative 3 is a negative 24. That cool?
I still don't what. So
Grant?
where did you get the negative 3 from?
In the book. There was here, negative 3.
Oh, I was looking at 40. Sorry.
Pardon? B is 24. Hey, now please, we're going lickety-split again, which happens so often in this class period. If you need to have more on that one, let me go, or we'll go to the next one. Okay, what's the answer to the next one? Okay, now we have a little problem. Notice there, we are going from 6 to 4. Okay, and then we have a 12 here, f of x dx. Now that's kind of confusing because I don't have any of those things, but how about this? Could I figure out, I'm going to use these two together a minute, and this is what I'm going to do. I'm going to go like this, which is, I'm going to go 1 to 6, f of x. Can you see on the board up all right? And that's a 5, right?
Yeah.
And then I'm going to have that equal, like this, from 1 to 4, f of x dx. Can you tell me what that's equal to? Very good. Now, I'm going to add from here. I need to go from 4 to 6 yet. Here's 4 to 6, f of x dx. See, now you're just so fast. That's negative 3.
Okay, can you just rewind and do that all over again?
Okay, this here is given.
Okay, yep. I got
Okay, that's a function from 1 to 6.
it. And then
Here, that same function is from 1 to 4.
given.
Okay, and now from 4 to 6 brings me all the way over here. Okay, now this doesn't make any sense in terms of the numbers here, but like this. The first one is from here to here. That's from here to here. Now this next one over here, this one here goes up to 4. See, this is 1, this is 4, and this is 6. And he tells me this is 8. Now, no, it doesn't make any sense when I've drawn it. So we have to figure out what is over here. That picture isn't very helpful. So this thing is a negative 3. Okay, now let's go back here. Okay, so this 12 could be taken out and put out in front, like this.
Negative 36.
And so, but,
It's flipped.
yeah, it's flipped. So this number is a 3, so my answer is 36. Question on that?
Oh.
From 4 to 6, it's a negative 3,
You
but
can
from,
just flip it and make
flip
it a negative. Okay.
right? Okay,
So why is it positive?
why is it positive? Notice this is from 4 to 6.
Okay.
Now I'm going from 6 to 4.
Oh,
See?
got it.
And that flips the number from a negative 3 to a positive 3. Okay? That's kind of fun. Now with that in mind, we have got enough information to do D. What's the answer to that?
-9.
Questions yet?
Yeah, don't do that out.
Okay, we know in that case, we're going from 4 to 6. We're going like this. We're doing this part right here. And it's 3 times it.
Okay.
Got it?
Yep.
Okay, would you go with me to problem 65 that's on the assignment? No, 61. Now, we've been doing some things with Riemann sums and with your calculators. Now, this problem, let's read what it says, and I'll tell you what I want. I don't want a lot. Riemann sums with midpoints. Oh, you with me? Midpoints.
No.
And a calculator. Okay? And it says in B, evaluate each sum using a calculator with n equals 50. It doesn't say that in the book. It says 20, 50, and 100. I don't want 20 and 100. I just want 50. You can do that one, no problem at all. Okay? And so that's all I want. And what I want you to do is set it up for me and then give me a number. And how do you set it up? I want to see sum and then the sequence. And I think if you can get this far, you're going to be all right in terms of knowing what that means. Now, I could make you manually do all these, but it's not any fun. Okay, yes.
So, is the equation just 2 square root of x, or how is the d of x affect?
Okay, this is going to be 2 square root of x, like
Okay,
that.
so the d of x doesn't affect it at all. Then?
Okay, now, Derek is saying this. What we're doing here, we have actually this kind of thing is a function, and this happens to be that delta x that pops out way in the back. That's what this turns out to be.
Okay.
Okay, close. We've got to do a limit, and I was going to do a little bit of it today, but I don't think I'll
So
get
it doesn't affect it at all?
big time, in some ways.
Yeah, but I mean,
Yeah.
it doesn't
No.
affect our numbers.
Okay, like in here, no, it doesn't, okay? Okay, good point. Then comma, you have to put an X, and then where do you start? Okay?
1?
Pardon? No, you don't start with 0.
1?
Where are we going from?
1?
1 to 4. 1 to 4.
We're going from,
1 to 4.
we're going from 1 to 4. So what's the first number?
1.
No,
No, 0.
no,
1.1.
no.
How many intervals are there?
What does it say? What did I tell you?
50?
Okay, there are 50 intervals. And where is the one, where's that f of x that's going up?
1.02.
Huh.
I don't know it in terms of decimal form. I know in fraction. What is the middle of that? What's how many intervals do we have? 50.
It's
So you're gonna,
1.9.
pardon?
It's 0.94.
1 and 1/50th.
There. That.
That?
Yeah.
It can't be.
That's 1.
We have to be between these two numbers.
Yeah. So don't you start at 1?
No,
Why not?
you tell me.
Oh, we're going from the middle, aren't we?
We're going from the middle.
No.
We're going from the middle. Okay? You have done some of them. That's why this gets a little tricky, and I want to see what number you have here.
I think I can.
I would prefer it in terms of a fraction,
Is it one?
and I don't know what it is right off the top of my head. Okay, and then where do you end?
But how do you figure it out?
You can figure that out.
1 and 100.
You've got a whole bunch of intervals from 1 to 4 here, and you're going to put 50 of them in between here. Okay,
So-
and here's going to be the first one, and I don't know what number's here.
To figure
And
out this,
what I'm going to do here is I'm going to the middle of it. That's what I want you to figure out.
yeah,
Yeah.
Got
but
it.
to figure out the stat, do you take 4 minus 1 divided by 50?
That is delta x.
And that's what
That's
you
the
need.
width of this thing.
That's what you need to.
And then we need the middle of that.
And you need the middle of that.
There you go, David.
Okay,
Finally.
now, so you got that down.
That's
The next thing I want to
Oh,
do,
question.
What?
Can you finish saying what
Nope.
has to go in those spots?
no,
Not what
that's
number.
that's
Not
what,
number.
that's what the assignment is. Okay? Because that's what you're going to do in a test. Okay? Just give me that, because I don't want a lot of other stuff. Okay, now, okay, the next question I have is this, I think. When you go to page 331, I don't know if I've got 5 up there. Okay, take a look at 5. Okay? Read it. So you're with me,
Which one, 55?
page 331, number 5.
Okay.
The
Okay.
three thirty number 5 there, right?
Okay? Okay? What do you think this is equal, this happens to be the sine curve, right?
Zero.
Okay?
Zero.
Okay, why? Same the top and the bottom. Okay? So that's gonna be 0.
Is it gonna be think cosine?
Pardon? Well, what do you think?
No.
Okay, he thinks not.
Wait.
Well, let's draw a picture and see what you think afterwards.
Probably.
We're going to be going here, here. These are my key points of graphing. And we'll go up here like this.
Oh.
Okay, half of one is here, the other half here, and this is underneath. So, okay, got it? Okay, here's my next one. I think I've got one here that'll work. I would like to have you figure out this one, and we're trying to make the integral the idea of some area stuff. Okay, so I'm going to go from a -2 to 2, and my function is going to be the square root of 4 minus x squared dx. Okay, let me tell you, this antiderivative is extremely difficult. I'm certain we're not going to be able to do it this year. But all I want is the geometric interpretation of this. So what is this area equal to? Okay, so we graph it. And this is a graph of what?
A half circle.
I like it. And a half circle is called?
A semicircle.
Good. Okay, now, in this case, what point is this?
-2.
Okay, and this point is?
2.
Okay, now what's this area?
The filled in
You should just carry the
semicircle.
circle.
The area of the circle is
Half. Yeah.
pi squared, and we need half of it.
2.
And so my answer is going to be,
Obviously, it's 2 pi.
okay, we're off to the next question then, see?
How do you get that?
A grant, you look spooky back there. But anyway, what part, do you understand this, Grant?
Yeah, I got the half circle.
Okay,
2 pi, what'd you fill in to get that? Just the two?
okay, from here to here is 2 units.
Just the 2, either way is 2.
Yeah.
units, Okay.
And that's because this is x squared plus y squared equals 4.
Yeah, and yeah, okay.
Okay? Any questions about that? Okay, now, a little bit dealing with some of your reading. Let's go to page 334. Now, when you go along, I don't want you to do a tremendous amount of trying to figure all these things out, but read along, and on 344, you get an area. He just says this, and notice it's here. I will be talking about it Monday and also Wednesday. Wednesday I'll really get at this thing like this, and just to point out a couple things to you. This is the area under the curve, and in this case, I'll probably just do a little function like this, and this is the t-axis. That's why that's there. Okay. And then we're going to be figuring out some areas in here like this, and this is the area we're talking about. And don't work. Some of you guys are not paying attention. Just wait, please. Page 344, 335. Look at it and see if you make some sense out of it. Same thing goes for 336, 337, 338. And then when you get, that's really one time over, maybe a little backup reading, but don't do an exhaustive job of it at this point yet. But then when you get on page 341, he has a number of examples there. Let's see. Really, most of it. Read it through, look at it, get confused, okay? And that's okay. So you have a little idea what the talking points are going to be, okay? Now, Then, I think I better quit, so I can, get these tests back and, spend some time.
Just leave
I do not have enough